Today we are going to examine how to relate a graph to its solution. So let's examine this given equation and the graph. A solution is a pair of values, which is x and y value, that make the equation true. So now, given the equation and the graph, we can find whether the points x and y, or the pair of points, are a solution for this equation or not. So now, to know that, we will use this equation and check if these points are a solution. We will check one value on the top, on the line of the graph, and one point that is not on the graph. So we will choose A and we will choose a B. Those two values, those 2 points only. So now let's write point A. So you can see point A, if you trace it, x will be a 0 and y will be 1. So the pair of points is 0, 1, which this two value gives us when x is 0, y will be a 1. So let's see if this is a solution for this equation. Let's rewrite the given equation, which is y equal 2x plus 1. You have seen before direct substitution, so we will use it directly. Where we see y, we will substitute for 1, and where we see x, we will put directly to a 0. So the y value based on this is 1. So 1 will be equal to 2 times a 0 plus 1. So 1 will be equal to 2 times 0 will be a 0, then plus 1, which indicate 1 will be equal to a 1. So this point is on the graph and it's a solution, then we will say this is a true. This point is a true solution for this equation based on the graph. So now let's choose the different point that is not on the line. So you can see x will be a 2 and y will be a 2. So when x is 2, y will be a 2. So those two values relate to x value will be a 2 and the y value will be also 2. So we can label as C that later on, and you can test this. So now let's write the given equation, which is y equal 2x plus 1. So y value will be 2. So we use direct substitution by replacing y to 2. Then if 2 times x is 2 times 2, then plus 1. Then 2 will be equal. 2 times 2 will be a 4, 4 plus 1. Which shows 2 is not equal to a 5. So this is false. So what have we learned in this? As you can see that any point that you select, you can select a point here. Let's use a different color. A point you can select here, which is on the line. You can select also here, or you can select here. Any point that on the line will be a solution for the equation. Any other point, if you select a point here, and point there, and point here, all those points are not on the graph, then it's not a solution. Those are false, and this is a true. So now let's see in different example. So we can see the example given is 4x minus 3y equal to 9, and this is the graph. So now let's choose a point. Any point that are on the line and a point that is not on the line. So let's see this point is on the line, which is, we find because x will be a 0 and y will be a -3. We can also choose this one is on the line, which is when x is 3, y will be 1. we can also choose a point that is not on the line. Which one can we choose? Let's choose this point. So what is the x value? X value will be a -2 and y will be a 3. Or we can choose when x is 2, y will be 1. So now let's just check this value and this. Let's check these 2 points and see if it's true. We already know that those 2 points, which is 0 and -3, is a solution for this equation, whereas 2, 1 is not a solution. But let's check. That's the 2 points that we're checking. So now let's do direct substitution. So the equation given is a 4 times x minus 3 times y equal to a 9. So we will use direct substitution for 0x and -3 for y. Then we have 4 times 0 minus 3 times -3 must be equal to a 9. Let's just put a question mark. We're going to check. So 4 times 0 is 0. -3 times -3 is a plus 9. That will be equal to a 9. So 0 plus 9 is a 9. 9 will be equal to a 9, which is a true. We will check. So now let's check the one that is not on the line, which is 2, 1. So we're checking it when x is 2, y will be 1. We're still using the same equation. Then 4 times 2 minus 3 times 1 equal a 9. So 4 times 2 is 8. -3 times 1 is a -3 equal 9. So 8 minus 3 is 5. Then 5 is not equal to a 9, so this is a 4. So that's how you check. Without even using a direct substitution, you will only check. If the point given on the line, yes, it's a solution. If the point given is not on the line, it's not a solution, without even doing a direct substitution. Because sometimes you may have a test that you have a time limit. You just check that. So now let's see a different example where you do not see a graph. You only see the equation on the point. So how do we check determine whether the ordered pair are solution for this equation? We just use direct substitution because every point is x, y. So now let's do the first one, which is a 0, 5. We will only check one value for this, and then we check the rest. You will be able to check. So x will be a 0 plus 2 times 5 equal to 10. So what's 2 times 5? 2 times 5 is 10. 10 plus 0 will be a 10 equal to 10. So this is a true. Put a check mark. So let's do the second one, which is 10, 0. So when x is 10, y will be a 0, which is 2 times 0. Must be equal to 10. So 2 times 0 will be a 0 plus 10 is 10. So 10 will be equal to 10. Then we'll write a check, which is a true. Let's check for this. Now we have 6, 4. We're still using the same equation. So when x is 6, then plus when y is 4 is 2 times 4 equal to 10. So 2 times 4 will be 8. 8 plus 6 is 14. So 14 is not equal to 10. So we will say this is not a solution. This is not a solution. So let's check the last one, which is 2, 4. So x will be 2, then it will be plus 4 times 2 no, it's reverse, it's 2 times 4. So when x is 2 and y is 4, we have 2 times 4 equal to 10. So 2 times 4 will be 8, 8 plus 2 is 10, 10 will be equal to 10, then that would be a true statement. So now you're learning when you have a graph, how to check the value whether it's a solution or not, and now when you don't have a graph, that you have to check one point at a time.